Hey, good afternoon, everyone, and thank you for attending today's webinar. This series is sponsored by the Colorado Energy Office with training materials created by Group 14. My name is Erica DeLello. I'm a senior PM at Noresco, where I work with the Colorado Energy Office to put on trainings just like this one. As you can see from the screen, we've got a whole bunch of other trainings or webinars that are on the docket upcoming. So I highly encourage you guys to join us for those as well. And we are in the second of 4 webinars for this specific series. And today, Anna will be talking about the HVAC and oh my gosh, hot water, service hot water. So we will dive further into that. But of course, we have other trainings that are available to you all, which you can request a virtual or in-person training for your organization or jurisdiction. And then we're also working on some on-demand courses, which are more go at your own pace. And those hopefully will be launched in December. All right. If you are a jurisdiction, you're looking at adopting the latest codes, we're here to help. We support the entire suite of I-codes and code adoption, touching on all of the items that you see here on the screen. But if there's something that you don't see and you're curious if we could support it, feel free to reach out. We do also have a whole plethora of resources available on the code toolkit, so definitely check those out. I've listed some of the latest ones on this slide. And then for another couple weeks, we're going to have an energy code resource survey available for those throughout the state of Colorado. If there's a resource that would be helpful for you all to have on hand, this is where you would submit your input. So I'll put that link in the chat shortly too. Last but not least is the Colorado Codes Helpline. It's probably my favorite resource where you can submit a question on any of the I-codes and a subject matter expert gets back to you in just a couple days' time. So definitely utilize this. It's a great resource. And with that, I guess just a couple housekeeping items. I did launch a poll. That poll helps us to understand how you found out about this webinar series. And then there will be a post-training survey. So if you're looking for AIA credits, that's where you'll put your AIA number, or just to give us some feedback so we can continue to improve on these webinars. It's all helpful. So, okay. I'm going to go ahead and stop sharing my screen and let you take it from here, Anna. And would you like me to moderate questions throughout, or would you like to hold to the end?
Yeah, normally I try to keep my eye on the questions, but if I miss one, because it's kind of nice to talk about it while we're going through it, I think.
Okay.
But I'll keep my eye on them too and see what pops up.
Okay, great.
Okay. Hi, everybody. Thank you for coming to the webinar. Today, for those of you who don't know me, my name is Anna McCullough. I'm energy team leader at Group 14 Engineering. I have been working with supporting the state on the development of the Model Low Energy and Carbon Code, and then also supporting the 2024 IECC and providing trainings like this for the last couple of years. So if you have any questions, feel free to type them in the chat, put them in the Q&A. You can always raise your hand as well if you have a question that you would like to talk about rather than just typing it. But we have a lot to cover today. Last week, we went over the structure of Section C406 and the Model Low Energy and Carbon Code. And then we did the architectural credits. Today, we're going to go over HVAC and service water heating credits, how they combine. And yeah, we'll get into it. So sorry, getting over flu cold situation. Okay, so the first section that we're talking about today, C406.2.2, is more efficient HVAC performance. Not all of these credits can be combined. We will talk through each one of these, and I'll try and remember to remind you all which credit things can be combined with as we're going through. So the different credits we have are H01, the HVAC total system performance ratio. We will talk about that on the next slide, so won't say anything now. Bated breath. H02 is more efficient HVAC equipment heating performance. H03 is more efficient HVAC cooling equipment and fan performance. H04 is residential HVAC control. H05 is a dedicated outdoor air system. We'll talk about all the requirements for that DOAS. H06 is evaporative cooling. This one was added by the Energy Code Board for the Colorado Model Low Energy and Carbon Code. So it's not in the 2024 IECC, but it is in the Model Low Energy and Carbon Code. And then same with H07, high efficiency heating credit alignment. So you can combine H02 with H07. You could do all of them. Well, it might be impossible, but you could try. You could do 3 of them, you could do 4 of them, any combination of H02 through H07. The only credit that H01 can be combined with is H04, the residential HVAC control. And that is because the TSPR method doesn't give you a way to take credit for that in the modeling. So let's start talking about them. H01, HVAC total system performance ratio, TSPR. As you all might know, the TSPR pathway is a pathway that was created as an alternate for section C403, which is the mechanical section. And that is in section C409. The entire section, you still have to comply with the mandatory requirements. You just completely, I'm so sorry. You completely substitute section C403 compliance with this TSPR method. It's a simplified energy model that calculates the impact of HVAC equipment efficiency on building loads. There are a lot of barriers to who can use the TSPR method. The only group occupancy types that can use the method are Group B, Group M, Groups R1 and R2, and Group E. There are other exclusions if you're using district systems, so district cooling, district chilled water, district hot water, district steam. If you have single package vertical air conditioners or heat pumps, you cannot use it. If you have PTAC, so package terminal air conditioners or package terminal heat pumps that have a cooling capacity greater than 12,000 BTUs per hour, you cannot use it. If you are using a common heating source for HVAC and service water heating, so aquatherm, basically, you cannot use it. And then any HVAC systems that provide recovered heat for service water heating cannot use this method. There are additional exclusions. I did not include them all in here because I could spend probably an entire hour talking about the TSPR method. It's a long section. But for the sake of section C406, the way that you calculate the number of credits is based on the outcomes of the model that you create. And this is a very simplified model, but what we would look at, your credits achieved would be equal to the base credits allowed in the tables in section C406, multiplied by the floor area served by the systems included in the TSPR. So if you can only provide 40% of your building can use the TSPR method, you could achieve these credits for that 40% of your floor area. So the ratio of that floor area times TSPRS divided by 0.05. TSPRS is the lesser of 0.20 and 1 minus the ratio of the reference building design divided by the mechanical performance factor. over the HVAC TSPR of the proposed design. So that ratio of the TSPR efficiency, 1 minus that, whichever is less, between 0.20 and that. So that would give you the number of credits. Just very quickly, this is how kind of just talking about the level of simplicity in the TSPR method. It is not a full energy model like you guys are used to seeing for section C407. It is truly just looking at the peak loads of the building, the efficiency of those systems, and the total energy use within the building. So on the left, you'll see kind of what a typical energy model would look like. And then on the right, this is the simplified model that would be used for TSPR compliance. We're really just looking at the HVAC systems. I did pull, there's a really nice study that was done by DOE on the types of systems that can comply with the TSPR method. And this is the example for large offices. If you have your base system for a large office is a water source heat pump with DOAS and ERV, and then it goes through the kind of comparison of all of the different system types and if they would comply with the TSPR method. So it does require additional efficiency over just the prescriptive requirements. Just looking through this, if you have a rooftop unit with hot water reheat, you're not going to comply with the TSPR method. I don't have an example of TSPR because I can't figure out the best way for a building to use it. We got a question. What software is used for a TSPR energy model? So the software, there is a DOE supported program that can provide the TSPR outputs, and it's available on DOE's website. It is not a mandatory requirement. Sorry, the second part of the question says, will it be required to be submitted as part of a building permit application similar to ComCheck or ResCheck that are usually requested by the AHJ? So if you are looking to substitute section C403 for the TSPR method, you would have to submit your inputs and outputs to the TSPR modeling program with your permit package, or if you are looking to achieve credits under H01. As we've looked through the model low energy and carbon code with different jurisdictions, with the state, we found that the TSPR method is not needed to show compliance with section C406. So it is completely, it's not going to be a mandatory requirement for the permitting process. That's a good question. Okay. The next credit is H02. This is more efficient HVAC equipment heating performance, and we will go through an example of this. So with this credit, not less than 90% of the total HVAC heating capacity serving the total conditioned floor area of the entire building shall comply with these two requirements. The equipment must be listed in the efficiency tables of section C403.3.2. I'm sure there are types of equipment that are not listed, but I had a hard time coming up with any. But somebody let me know if you can come up with one. Those are all those mandatory tables that you guys are used to seeing in section C403. And then the other requirement here is that electric resistance heating capacity has to be limited to 20% of the total system capacity, excluding supplemental heat. So all of those electric resistance coils you have as backup for your heat pumps aren't included in this 20% calculation. But if you are providing, you're like a small restaurant and you have a kitchen makeup area unit that is an electric resistance heating kitchen makeup air unit that is greater than 20% of the total capacity of the systems in the building, you would not be able to use this credit. And then the heating efficiency of the systems that you are taking credit for must exceed those tables by not less than 5%. So those tables in section C403. If you exceed those efficiencies by greater than 5%, you can gain additional credits. So you multiply the base credits that are listed in the C406 tables based on your occupancy. You multiply it by HEI divided by 0.05. HEI is the lesser of 0.20 or the design heating efficiency divided by the required heating efficiency minus 1. So we'll go through an example. Oopsie. This is an example of a split heat pump. So you'll see the technical specification for this example piece of equipment on the left there, and then at the bottom we have the requirement for that piece of equipment from section C403. So we assumed a commercial multifamily building in climate zone 5B. All units are being served by these heat pumps. The base credits for a multifamily building in climate zone 5B for H02 is 5. And you'll see here that we're just assuming this 9.5 HSPF2 for the sake of this very short presentation. So we're going to calculate our HEI, which is going to be the lesser of 0.20 or 9.5 divided by 7.5. So my 9.5 HSPF2 divided by that 7.5 HSPF2 I have highlighted down there, minus 1. So that gives me a 0.27. 0.20 is less than that. So then we're going to have 5 times 0.20 divided by 0.05, which gives me 20 credits. So a fair number of credits available there. The next credit, H03, is very similar, except for its cooling. And then you also have to look at fans with this credit. So this one is a little bit funky. So it's similar, but it's a little funky. Same requirement around 90% of the total HVAC cooling capacity serving the total conditioned floor area of the entire building shall comply with these sections. So the equipment must be listed again in that section C403.3.2. We have to know what we're comparing it against. But again, it's hard pressed to come up with a system that isn't included in the tables in section C403. And I'm sorry, it should say cooling efficiency there. The cooling efficiency must exceed the requirements by not less than 5%. So again, that same 5% that we were looking for with the heating efficiency. For water-cooled chiller plants, the heat rejection equipment performance in table C403.3.27 shall also be increased by at least the chiller efficiency improvement. So you want to see that same minimum 5% effectiveness improvement for your heat rejection equipment. Where fan energy is not included in the packaged equipment rating, fan power or horsepower shall be less than 95% of allowed fan power in section C403.8.1. So basically what we're looking for there is if the unit that we are specifying does not include the energy, or the cooling efficiency doesn't include the energy of the fan, then we need to make sure that it is also at least 5% better than the allowable fan power. Again, there are additional credits available. The lesser of 0.20, I'm sorry, it's the base credits times CEI divided by 0.05. And CEI is the lesser of 0.20 or the design cooling efficiency divided by the required cooling efficiency minus 1. Asterisk, asterisk. If your metric decreases as efficiency increases, kilowatts per ton comes to mind, then you invert that fraction when you're calculating your CEI. But we're going to take that same heat pump that we were looking at for our heating efficiency, and the base credits here should actually say 1. We take our 20 SEER2 cooling efficiency listed here in our specification, divided by 14.3 SEER2 that's required, minus 1, that gives us a 40 ratio of 0.4. The lesser is 0.2, so we're going to say 1 times 0.2 divided by 0.05 equals 4. So many fewer credits available under the cooling energy efficiency, additional energy efficiency credit when compared to the heating for multifamily buildings in climate zone 5B. But the same process here. Sorry, I know I'm going fast, but there's a lot of credits we got to talk about. H04 is residential HVAC control, and this one's interesting. So in this credit, and again, this is only available for dwelling or sleeping units. Other occupancy types cannot use this credit category. So HVAC systems serving dwelling or sleeping units shall be controlled to automatically activate a setback of at least 5 degrees for both heating and cooling. The controller has to be configured to provide setback during times when the residential unit is unoccupied, but then also during occupied sleep periods. And then the occupied setback mode has to be configured to operate in conjunction with one of the following. You do not have to comply with all 4 of these. And I really tried to simplify them. There's additional information available in the code around each of these. I'm happy to answer any questions you have. The first is like a master switch at the dwelling unit main entrance. So the switch, it's like you walk into a hotel room and it has a master switch. It activates the setback and non-ventilation mode for all HVAC units in the dwelling unit. So you turn the switch off, you're leaving, it's going to set back your HVAC. The second option is to provide occupancy sensors in each room combined with the door switch. So where separate, and this is helpful for separate rooms, if you have like a PTAC in every room, it's a multi-room unit. Where separate room HVAC units are used, an individual occupancy sensor on each unit that is configured to provide setback shall meet this requirement. Third option is an advanced learning thermostat that recognizes occupant presence and automatically creates a schedule for occupancy. You see a little example there of one of those thermostats, and it has the occupancy sensor you can put in your house. And then an automated control and sensing system that uses geographic fencing connected to the dwelling unit occupants' cell phones, and then sets back when the cell phone leaves the area of the unit. I thought that one was very interesting. I'd never heard of that. So just basically ways to try and reduce the heating and cooling loads and the heating and cooling energy use that those units in the residential units are providing when no one is in the space or when occupants are sleeping. We got a question. What happens with radiant floor systems that do not operate correctly with setback thermostats? They cannot use this credit for compliance. There's no exceptions for different system types. If the system that you're installing doesn't work, then you can't use this credit for compliance. It's a good question. The next section or next credit section is H05 dedicated outdoor air system. So this is more complex than what we were used to under the 2021 IECC. And there are quite a few additional requirements. So just to begin with, you are only allowed to use this measure where single zone HVAC units are not required to have multi-speed or variable speed fan control in accordance with section C403.8.6.1. So if you have rooftop units, for example, or you have large furnaces with split DX, you need to look and see if you are required to have a variable speed fan in accordance with section C403.8.6.1. Section C403.8.6.1 requires that any unitary DX cooling system with a mechanical capacity greater than or equal to 65,000 BTUs, or any chilled water or evaporative cooling with a fan motor size greater than or equal to 1/4 horsepower, to vary the indoor fan airflow as a function of load. So if you have, I'm sorry, I should have done this math beforehand, a 5.4 ton DX unit or greater, you have to be varying your fan speed as a function of the cooling load. And what that means is that you can't then comply, you can't use credit H05 under section C406. But if you have like VRF, or if you have fan coil units, or maybe not fan coil units, I guess if you had split DX, you could do it. But anyway, you see there are systems that you can use for compliance with this pathway. So the requirements of section of credit H05 are that you provide, you have to, your zone controls have to cycle the heating and cooling unit fans to off when they are not providing required heating and cooling. So what they're looking for here is to have the DOAS, your ventilation system, is going to be providing ventilation air completely separate from your zone units, those VRF units, your fan coil units, whatever you have. Your outdoor air has to be supplied by an independent ventilation system, a DOAS, designed to provide not more than 130% of the minimum outdoor air required by section, by the IMC to each zone. So they don't want you to be over ventilating the spaces. Your ventilation system shall have energy recovery with an enthalpy recovery ratio of 65% or more at heating design. Sensible energy recovery ratio can be used in lieu of latent if you don't have to provide cooling energy recovery or dehumidification. Where the ventilation system serves multiple zones, partial economizer cooling shall set the energy recovery leaving air temperature at 55 degrees based on representative building loads. This excludes latent energy recovery for dehumidification. So the idea here is that if it is cool enough and the building is in cooling, we want to provide outdoor air economizer temperature air to the building rather than using our energy recovery. So we're going to bypass that energy recovery wheel when it makes sense. Credits are adjusted if all of the floor area in the building can achieve this credit, or if the enthalpy or sensible energy ratio recovery is less than 65%. And so the way they do that is by this equation here. So we're going to have the credits that are achieved equal the base credits from the table from section C406 times the fraction of the floor area served. So think about like a office building, your conference rooms are using rooftop VAV units, so they can't achieve credits under section H05, and the rest of the building is DOAS with ERV and VRF. So you're going to take that fraction, whatever it is, 80% of your building. And then if your cooling or heating enthalpy or sensible energy recovery ratio doesn't meet that 65%, you're also going to have this ERE adjustment factor. And we'll go through an example here, but you'll see here that if your cooling energy recovery ratio is at least 60%, your heating enthalpy recovery ratio is at least 60%, then your ERE adjustment factor is 0.67, and it goes down from there. That 65% is the base requirement of H05, and so your adjustment factor is 1.0. If you have a ERV that has a greater than 65% effectiveness of heat recovery ratio effectiveness, you do not get additional credits. So here's our example. We have an office building with VRF. Our energy recovery ratio is only 60%, and we're in climate zone 6B. We're going to take the base credits, which is 70. I'm saying that the entire building is served by this system. So we're going to multiply it by the fraction of floor area served, which is 1.0, and we're only at 60% effectiveness. We're at 0.67. So we're going to 70 times 1 times 0.67 gets us 47 credits. H06, evaporative cooling. So again, this one was added by the code board for the model low energy and carbon code. This one is not in the 2024 IECC. So this one just has 1 or 2 credits available. I believe it's just 1 across the board though, for different occupancies in the different climate zones. And 80% of the total HVAC cooling capacity serving the total conditioned floor area of the entire building or tenant space is provided with evaporative cooling. That evaporative cooling has to be installed in accordance with section 928.1 of the IMC. There's no calculation here. If 80% of your cooling capacity is in the form of direct evap, you can achieve this credit. And this is what direct evap is, if no one is aware. Or if you are not aware, you just have water running down. It's just a swamp cooler over an evaporative pad. The hot air goes through the evaporative pad, it absorbs that water, and that makes it cooler. H07 is the high efficiency heating equipment credit alignment. Say that 5 times fast. Again, this one was just created for the model low energy and carbon code. I do not have an example of this calculation because the base credits are not available yet. The state is working with PNNL to do the modeling to calculate what those credits should be, and they haven't received them yet. We got a question. Can H06 and H07 be combined with all other HVAC credits? It cannot be. We can go back to the first slide. The only credit that H01 can be combined with is H04. All other credits can be combined together. So H02 through H07 can be combined together in any way, shape, or form, but it can't be combined with H01. Good question. So the idea here is that if you have not less than 90% of the total space heating capacity serving the conditioned floor area of the building or tenant space served by electric space heating equipment that meets or exceeds the heating efficiencies listed in section C403.3.2, so those tables that we've been talking about, you can achieve a fair amount of, well, we'll find out how many credits. I guess I can't say a fair amount. But the way that this will be calculated is you'll take the base credits from the tables in the model low energy and carbon code, multiply them by the minimum required efficiency in section C403.3.2, subtract 0.8 from that and divide it by 2.1. And you can do that for each type of HVAC equipment that you have in the building that achieves this requirement. But again, they must be electric. Any natural gas wouldn't achieve these credits. Okay. The next section, we're going to start talking about service water heating. Does anyone have any additional questions on the HVAC credits before we start talking about service water heating? Okay, we'll keep going then. Please feel free to raise your hand, put them in the chat, put them in the Q&A if they come up. These are a little messier in how you can combine or cannot combine them. So these are the pathways that are allowed. W01, W02, and W03, you can only choose one of them. Asterisk, you can kind of combine them, but there are credit maximums. So you can only achieve a certain amount of credits by combining them. I didn't think we had enough time to go through those combinations. But basically, if you achieve like 75% of the available credits under W01, you can only achieve 25% of the credits available under W02, for example. So it's just those combinations of how you can combine them, because the credit values can be so high for different occupancies. They didn't want you to achieve all of your credits under renewable energy or under service water heating. So W01 is recovered or renewable water heating. W02 is the heat pump water heater. W03 is the efficient fossil fuel water heater. So if you're providing, and we'll go through all the verbiage for each of these, but if you're providing, on-site solar hot water, you would go under credit W01. If you're providing a highly efficient heat pump water heater, you get W02, or if you're a condensing gas water heater, you can achieve W03. W04 is the service hot water piping insulation increase. So we'll go over what the required level of insulation is there. W05, W06, or W07. You can choose one of those. So W05 is point of use water heaters. W06 is thermostatic balancing valves. W07 is a heat trace system. And then you have W08, 09, and 10. W08 is water heating system submeters for residential occupancies. W09 is service hot water flow reduction. We'll get there. W10 is the shower drain heat recovery. You can combine, you can combine the above. So you can combine option 1 with 2, with 3, with 4, with 5, with 6, as long as you're only selecting one measure from option 1 of this slide and one measure from item 3 on this slide. So you can see how I tried to break this up to make it clear as to what the different combinations could be. So you could have a condensing gas water heater, you can increase the insulation on your piping, provide thermostatic balancing valves for your residential units, and then also provide submeters and shower drain heat recovery. You could do all of those and get a whole lot of credits. Okay. W01 is recovered or renewable water heating. I'm so sorry. I have a fruit fly that is attacking me. So the building service water heating systems shall have one or more of the following that are sized to provide not less than 30% of the building's annual hot water requirements, or 70% of the building's annual hot water requirements if the building is required to comply with section C403.11.5. Section C403.11.5 requires, my goodness, heat recovery for service hot water for a facility that operates 24 hours per day and has installed has heat capacity, my goodness, and installed heat capacity of water-cooled systems exceed 6 million BTUs of heat rejection, and the service hot water load exceeds 1 million BTUs of heat rejection. So the only building type that I could think about that would achieve this would be like a giant hotel in the mountains that is providing water-cooled chillers with and they have like a huge spa, and maybe not even in the mountain. It would have to be in the, we'll say it's in the Front Range. But anyway, so just a giant hotel with like a spa and a huge pool, and they have this huge service hot water heating load. But then they also have a very large heat rejection, and they have water cooled chillers that are providing that heat rejection. That building is going to be required to provide heat recovery for that service hot water. So we're talking about utilizing the heat recovery from the chillers to preheat the domestic hot water. If you are that building and you want to achieve credits under W01, you have to provide 70% of the building's annual hot water requirements to achieve credits under this. Okay, so what recovered or renewable water heating technologies count towards W01? It's waste heat recovery from heat recovery chillers for preheating of service hot water, or process waste heat from process equipment. A water-to-water heat pump that pre-cools chilled water return for building cooling while heating service hot water, or on-site renewable energy water heating systems. We have a little example of that there, that solar hot water. W02 is a heat pump water heater, and there's no calculations for W01, which is very exciting. So under W02, if you have an air source heat pump water heater, it has to be sized to meet at least 30% of the design and use service water heating requirements at an outdoor air temperature of 67.5 degrees. Where your heat pump exceeds 50% of the design and use load at 67.5 degrees outdoor air temperature, you can achieve additional credits. So you're going to take the base credits from the tables in section C406, divide them by 0.5, and then multiply that by the capacity of your heat pump water heater divided by the end load. So the capacity of the heat pump water heater is at a 50-degree entering air temperature and a 70-degree entering potable water temperature without supplemental heat. So it's just the capacity of that heat pump. If your capacity of your heat pump water heater divided by the end load is greater than 2, you can only use 2. The efficiency of your heat pump water heater must meet one of the following: a UEF of 3 or a COP of a minimum of 4 at 50 degrees entering air and 70-degree entering potable water temperature. So requirements around the efficiency of those heat pump water heaters, and then additional credits available for serving more of the building, total building load. W03, efficient fossil fuel water heater. The combined input capacity weighted average equipment rating of all gas water heating equipment in the building shall not be less than 95% or a 0.93 UEF. If your service water heating system is required to comply with section C404.2.1, you can only achieve 30% of the base credits. Section C404.2.1 is requires higher efficiencies for high capacity gas fired water heaters with a total input for the bill where the total input of the building is 1 million BTUs per hour. you do not include any water heaters for individual dwelling units in that calculation. So it's going to be a huge rec center. Or like a hotel with central domestic hot water. A second adjustment for W03 is if the installed service water capacity is less than 200 kBTUs and the weighted UEF is less than 0.93 UEF and not less than 0.82 UEF, you can only achieve 25% of the base credits. But for the most part, you install condensing water heaters, you have a large load, you're going to achieve these credits. W04 is service hot water piping installation increase. Where your service hot water is being provided by a central system, the installation thickness shall be at least 1.5 times the thickness required in section C404.4. So what I did was I took that table from section C404.4 and I just took this one temperature range because I don't know, wanted to just use it as an example. So we're looking at a temperature range of 105 to 140. Based on your pipe size, this is the amount of insulation that's going to be required to achieve credits under W04. If 50% or more of your hot water piping does not meet this requirement because you're installing it in partitions, then the credit shall be prorated as a percentage of lineal feet of piping with increased insulation. So if you can just increase the installation for the piping that's in the ceilings of your multifamily building, you can't include it, increased insulation in your soffits, for example, then you would only use that, you would use that ratio to calculate how many credits you achieve. W05 point of use water heaters are only available for group B or E buildings larger than 5,000 square feet. And you have an example here of a little point of use water heater. You cannot have a recirculating system or heat trace piping except for in commercial kitchens or showers in locker rooms. Your supply piping must be insulated to the level shown in table C404.4.1. So this one wouldn't comply with that because the piping isn't insulated. And then the maximum water volume in the piping from water heater to termination of any individual fixture must meet the requirements based on a fixture type. So I believe it's like 2 ounces for a faucet, something like 8 ounces for a sink, things like that. As I should have said lavatory instead of faucet. W06, cruising through. Thermostatic balancing valves. So for a central water heater with a recirculating system, each recirculating branch return connection to the main service hot water supply piping shall have an automatic thermostatic balancing valve set to a minimal return water flow when the branch return temp is greater than 120 degrees. And so the idea here is that we have this thermostatic balancing valve. We are circulating 5 GPM down this branch. We don't want to be returning a bunch of really hot water into the return. We know that our condensing water heaters and heat pump water heaters operate at a higher efficiency when return water temperatures are lower. So we're going to reduce the demand there and return less hot water into the return piping. And here's an example of, these are the little thermostatic balancing valves, reducing the flow into the return water because the water's too hot. W07 is a heat trace system. So this is only available for projects with a gross floor area greater than 10,000 square feet, and they must have a central water heating system. Systems shall include self-regulating electric heat cables, connection kits, and electric controls. And the cable has to be installed directly on the hot water supply pipes underneath the insulation to keep that water warm. If you are a group R2 occupancy served by a central service water heating system, and you provide each unit with a service hot water meter connected to a reporting system that provides individual dwelling unit of domestic hot water use, you can achieve credits under W08, but that is the only project type that can. W09 is service water flow reduction. This is only available for dwelling units, sleeping units, and guest rooms. And the plumbing fixture flow rates must be less than or equal to the following values. We're going to comply with, we're going to comply with most of these just because of the water sense requirements in Colorado. And lastly, shower drain heat recovery. So cold water serving showers shall be preheated by shower drain heat recovery units, and that's what you're looking at here on the right. The efficiency of these units has to be 54% or greater to achieve credit under W10. So the idea here is that you have a shower and it's warm, you're showering in warm water, that warm water goes down the drain. So what they do is they take a copper pipe and you have your incoming cold water and you wrap that copper pipe. Well, like it's a piece of equipment, but they wrap the copper pipe around your shower drain, your main, and that preheats the water that's going to the water heater. So now all of that heat that you're just flushing, letting go down the drain of your shower, is being recovered within your system. These credits are only available for the following occupancies: I2, I4, R1, R2, and E if you have more than 8 showers in your school. I've seen this a couple of times, mostly on hotels, where they have kind of large stacks of hotel rooms and you can preheat the water that way. If you cannot provide this system for ground floor showers. So if all of your other showers, you're providing the system, but not on the ground floor showers, you just adjust the credits for the number of showers that do have the drain water heat recovery. And so you take the base credits times the showers with heat recovery divided by the total number of showers to get your total number of credits. I like that they included this calculation here, especially on this one, just because there are a number of reasons why you can't provide drain water heat recovery for units or showers that are on the ground floor of your building. They're just not effective in the horizontal direction. So that's it. I'm so sorry. That was so much, but we got through all of those credits. If we have 5 minutes left, if anyone has any questions, my email's there, my phone number as well, if you want to reach out as you're reviewing the slides, if you have any additional questions.
Thanks, Anna. I know that was a lot to go through. The service water heating and the HVAC are big topics, to say the least. Donald, I see your question about the PDF of slides. There will be slides posted to the code toolkit. Usually Colorado Energy Office does that within a week or so, so keep an eye out for that. All right, any other questions? Feel free to write those in the Q&A or go ahead and raise your hand and we can unmute you to ask Anna directly.